Hello everyone. Today we will discuss about the cost behavior. What does mean cost behavior? Cost behavior is the study of relationship between cost and activity driver output. So what does mean activity driver? The activity driver is the factors are causing the cost. For example, in the purchasing activity, the driver can be number of order. In setting up machine, for example, the driver can be number of setup. In the production, for example, the driver can be units produced. In cutting, for example, the driver can be machine hours. In the assembly, for example, the activity driver can be direct labor hours. So actually, the activity drivers in the broad sense, not only the units produced. So in the broad meaning. So actually the cost in this case, we can look at from the total cost and the cost per unit. So if the output of the activity driver change, so how is the total cost and how is the cost per unit? Actually in this case, there are three possibilities. The first possibility, when the activity driver output changes, the total cost also changes while the cost per unit remain constant or unchanged. So we can classify if the cost behave like this as a variable cost. Variable cost. And then we can I can give the example. So, for example, 1 unit of donuts requires 1 egg, and then the price per unit of egg is 1,000. So it means that to produce 1 unit of donut, the raw material cost in this case 1,000. 1,000 to produce 1 unit. So if we produce 100 units, so what is the total raw material cost? Will be 100,000. So 100 unit times 1,000. If we produce 1,000 units, so what is the total raw material cost? Direct raw material cost will be 1 million, 1,000 times 1,000. If we produce 5,000 units, the total raw material cost will be 5 million, 5,000 times 1,000. So from this table, we can see that the cost per unit unchanged or remain constant, while the total cost change. The more units, the more cost. Less unit produced, less unit cost. So how is the changes of the total cost? The total cost will change proportionately because we have slope, right? We have coefficient 1,000. So if we just produce 1 unit, our direct raw material cost will be 1,000, 2 unit, 2,000, 3 unit, 3,000 rupiah. So proportionately, while the cost per unit actually remain constant in the relevant range. So we have relevant range. More than the relevant range or lower than relevant range, the cost will change. For example, if we buy more eggs, so we will get a discount, right? Quantity discount. For example, if we just buy until 5,000 units, the price still 1,000. But if we buy greater than 5,000 unit, we can negotiate, and then we will get a discount. For example, the price not anymore 1,000, but we can buy 900 rupiah per units. Yeah, because we buy many large quantities, yeah, of eggs in this case. So it's mean that the costs remain constant until 5,000 unit. The cost per unit is, I mean cost per unit remain constant, yeah, until 5,000 units. Greater than 5,000 unit, they will decrease to 900 per unit. So will decrease to 900 from 5,000 to 900. So we can look at the graph. In this case, the total cost, yeah, graph should be like this. No production, no cost, more production, more cost. If we produce 5,000 units of donuts, so the total direct raw material cost will be 5 million. Yeah. So we can make the formula Y equal 1,000 X. X in this case, the units produced, the unit produced. So we just replace by the units produced. So we can estimate how much our direct raw material cost if we produce, for example, 4,000. So X replaced by 4,000. So the total will be 4 million. And then if you look at from the cost per unit graph, yeah, the graph, yeah. So you can see here 1,000, yeah, remain constant. Actually remain constant in the relevant range. Yeah. We buy 1 unit of X, 1,000, 2 unit, 2,000, 3 unit, 3,000, yeah, 3,000. So the unit costs remain constant. So how can we define the variable costs? So we can define the variable costs, yeah. Costs in total, yeah, cost in total change, yeah, with the changes of the activity driver output. But the changes in this case proportionately. Yeah. So cost in total change proportionately with the changes of the activity driver output, while the cost per unit remain constant in the relevant range. Yeah. So we can define, we make a definition based on this exhibit. Yeah, exhibit. Next, possibility, if the activity driver output change, yeah, the total cost remain constant or unchanged while the cost per unit change. So we can classify this cost, yeah, as a fixed cost. As fixed cost. Yeah. So if the activity driver output change and the total cost unchanged or remain constant while the cost per unit change, so we can classify as fixed cost. For example, to produce a donut, we have one oven with a normal capacity 5,000 units, and then we depreciate, yeah, with the depreciation expense 500,000 per year. So if we produce 100 units, so we have the same depreciation expense 500,000, and then the cost per unit, the depreciation expense divided by production, yeah, the unit produced, we have 5,000 units. If we produce 1,000 units, so because the depreciation expense is the same, so the cost per unit will be 500. So 500,000 divided by 1,000. If we produce 5,000 units, so the cost per unit will be 100. 500,000 divided by 5,000. So it means that the more units produced, the less cost per units. Yeah, the less cost per units. Yeah. Because the depreciation expense is constant. Yeah. So in this case, we can see that cost per unit change. Yeah. And then the total depreciation expense remain constant. So how is the unchanged? How is the the total cost? Actually, the total cost in this case remain constant in the relevant range. Yeah. So greater and lower than relevant range, yeah, the total cost will change. Yeah. For example, if the demand, yeah, the demand of our product greater than 5,000 units, so we cannot, one oven is not sufficient anymore, so we need to have more oven. For example, if we have two oven, so the depreciation expense will be 1 million. If we assume that the depreciation expense seems, yeah, because we have two oven. One oven is 500,000 per year. If we have two, yeah, so the total depreciation expense will be 1 million. So the total will be changed. Yeah. Yeah. If, for example, yeah, because we have capacity for one oven 5,000, if the demands greater than 10,000 units, so it means that we need 3 oven, we need one more oven. Yeah. But we have capacity 15,000 units because one oven is 5,000 units. But our depreciation expense will be 1,500,000 units, 500 units. Yeah. So it means that in the relevant range, yeah, remain constant in the relevant range. So if we assume our relevant range, yeah, 5,000, yeah, from 0 to 5,000, so our depreciation expense will be 500,000. But if we assume our capacity, for example, from 5,000 to 10,000, so depreciation expense will be 1 million. 1 million. Yeah. So we can look at the, how about the cost per unit? The cost per unit will be changed in the opposite direction. In the opposite direction. Because the more units, the lower cost per unit. The less unit produced, yeah, the higher cost per units. Yeah. And then if you look at from the graph, so like this, the total depreciation expense remain constant, yeah, regardless the unit produced. Yeah. So we can make a formula Y equal 500,000. The cost per unit graph, you can see here, no production, for example, we still depreciate the oven, yeah, our oven. So the actually the total cost per unit will be 500,000. Yeah. But if we produce 5,000, so the unit cost will decrease significantly to 100. So we can define the fixed costs. Costs in total remain constant in the relevant range, yeah, regardless the changes of the activity driven output. Regardless the changes of the activity driver output. While the cost per units change in the opposite direction. In the opposite direction. Yeah. Opposite directions, as I explained just now, the more unit produced, the lower unit cost, and otherwise. And then the third possibility, if the activity driver output change, the total cost also change and the cost per unit also change. So we can classify as semi-variable cost. Semi-variable cost. Yeah. For example, to produce 1 unit of donut, we need 1 kilowatt hour for electricity. And then, for example, our electricity is postpaid, not prepaid, yeah, postpaid. In Indonesia, actually, we have for postpaid, yeah, actually we have two kinds of charge. The first is the fixed charge, yeah. For example, 1 million, yeah, per year, and then kilo hour rate, yeah. Kilo hour rates, yeah. KWH, yeah, kilo hour, yeah. Kilowatts hour, yeah. Kilowatts hour, yeah. For example, rate, for example, 1,000 per kilo hour, kilowatts hour, kilowatt hour. So if we produce 100, because we have a fixed charge, in this case 1 million, and then we will actually the kilowatts hours charge will be 100 times 1,000, so will be 100,000. The total electricity expense will be 1,100,000, 1 million plus 100,000. So what's in the cost per unit? The cost per unit, the total electricity expense divided by 100, so will be 11,000. If we produce 1,000 unit, we have fixed charge, and then the kilowatts hour cost, yeah, will be 1 million. So 1,000 unit times 1,000. So the total will be 2 million. 2 million divided by 1,000, so the cost per units, yeah, in this case, cost per kilowatt hour will be 2,000. And then cost per unit in this case. If we produce 5,000 units, we have same fixed charge or abonnement, actually in Indonesia we call. And then the kilowatts hours cost 5 million. So 5,000 times 1,000. So the total will be 6 million. 6 million divided by 5,000 will be 1,200. And 200. Yeah. 200. Yeah. So, so in this case, the total electricity expense, yeah, change, but not proportionately. Yeah, not proportionately. While the cost per units change in the opposite direction. Yeah, in the opposite direction. In this case, the more unit, the less cost per units. Yeah, cost per units. And then the total cost graph will be like this. So this is the fixed charge. And then this is fixed cost, and the kilowatt hour we classify as variable cost. So it's mean that in one cost, there are two kinds of, consist of the fixed cost and the variable cost. So this one, from this and this is fixed cost, and this one from this we call variable cost. Okay, variable cost. So we can make the formula 1 million plus 1,000 X. Yeah. X in this case actually kilowatts units, yeah, unit produce, yeah, unit produce, because to produce 1 unit we need 1 kilowatt hours. Yeah. Actually this is units. The more so we can replace this by units produce. And then if you look at from the cost per unit graph, yeah, yeah. Actually the graph like this. The more unit produce, we have the lower cost per unit. So we can define the semi-variable cost, cost in total, and cost per unit change with the changes of the activity driver output. So in total change, and also the unit cost change with the changes of the activity driver output. So actually we can make conclusion, right? In variable costs in total change with the changes of the activity driver output, while the cost per unit remain constant. The total cost change actually proportionately. The unit costs remain constant in the relevant range. And then fixed costs in total remain constant in the relevant range regardless the changes of the activity driver output, while the cost per unit change in opposite direction. And then the semi-variable costs in total and per unit change with the changes of the activity driver outputs. That's all our meeting for today. And then I will continue to the next topic, how to separate or to break down the semi-variable cost into fixed cost and variable costs. And after that, I will also explain the difference between the functional based cost behavior and the activity based cost behavior. The functional based cost behavior actually is traditional cost behavior, and the activity based cost behavior is contemporary cost behavior. Thank you.